Algebra 2, we're at 7.8b now, and we're going to talk about absolute values of complex numbers. We also have 23 previous videos for Chapter 7. So if you start watching this video and you get confused, I want you to click on the links in this description, and you'll be able to watch those previous videos that you might have missed, especially the 5 previous videos that we talked about the imaginary number I, okay? We know the absolute value of a real number can be thought of as its distance from 0, and we can think of the absolute value of a complex number in a similar way. So here's a definition. The absolute value of a complex number, a+bi, is denoted as the absolute value of a+bi. We just put the bars around it, see? And it's defined as the square root of a² + b². So we're going to use this to find some absolute values of some complex numbers. So take a look at this graph here. Here's the imaginary line. Here's the real line. We talked about that in the last couple of videos. So we can see from this graph that the length of that green segment right here, drawn from the origin to a+bi right here, is the square root of a² + b². See? And this quantity is a real number. It's called the absolute value of a+bi, and it's written like this with the absolute value bars, the absolute value of a+bi. So we can find the absolute value of -3 + 4i. We put it into a radical sign, and we've got -3 squared + 4 squared. And that's going to make a +9. That's going to make a 16. 9 and 16 is 25. So we've got the square root of 25, which is 5. See? This is pretty easy, all right? We can find the absolute value of 4 minus 3i. We're going to substitute 4 and -3 for a and b. So here we've got the 4 minus 3i. We need to be a plus, so we've got 4 squared plus -3 squared. See? That's going to give us a 16 and a 9, and we've got 25 again. Square root of 25 is 5. See? So do you see how this had a minus sign, and the other ones had a plus sign, and it's supposed to be plus? So what I did was I put it in parentheses, so we could keep our plus sign. See that? If you see it like this, we can just substitute C and D for A and B. C minus DI, the absolute value, would be the square root of C squared plus D squared. Okay? And remember that there's a little invisible 1 in front of this I. Okay? So if you see the absolute value of 1 plus I or some number plus I, that's 1 squared plus 1 squared because there's an invisible 1 there, like this. See? They just don't write the 1. So 1 plus 1 is 2, so we've got the square root of 2. See? And if you don't see a value for A, if there's no, A plus something here, some value plus something, like up here, that means A is a 0. So you got 0 plus 3i, see? Which is basically just saying 0 squared plus 3 squared. So that would just be the 3 squared. That would be a 9. So the square root of 9 is 3, see? Our next video is 7.9a, and we're going to talk about equality for complex numbers. I'm going to add this video to the Algebra 2 playlist, and the only thing that can really cover this would be the Chapter 11 playlist from Algebra 1 that was about radical expressions and equations, but they really don't talk about imaginary numbers. And you have to watch at least the 5 previous videos for I if you haven't seen them for imaginary numbers so that you don't get lost or confused, okay? Because I keep saying you don't want to skip steps on the ladder. You could still climb it, but it's going to be harder, right? And also, please remember that you can go to patreon.com and become a monthly patron for just $1 or $2, okay? So, I'm trying to make ends meet on Social Security, and it's not going as well as I'd like. So anybody that I've helped, I'd really appreciate their help in return, all right? I'm proud of you. Keep watching math videos. You'll be fine, all right? I believe you. Bye.